Hey guys, happy Thursday to everybody. It's Jim from Intrepid Sea, Air, and Space Museum. One more time coming at you with another live Intrepid Adventures program, another live stream. And by the way, these things don't just happen, they actually cost resources. So if you might want to consider supporting programs like this and to keep these free programs flowing, please be sure to click the link in the chat and you will be taken to a place where you can really help us out a lot. Okay. All right. So as I said, I am here broadcasting from the Intrepid Sea, Air, and Space Museum. Feel free to say hi in the chat. Tell us where you're from. Say hi. You know, we love hearing from you guys all the time. Okay. Now today's program is high flying design, and we're going to talk about aircraft and how they fly. And today we actually have an activity at the very end of the broadcast. Today we're going to be making our own aircraft. That's right, a paper one, okay? So if you want to follow along, please get yourself a couple of things. Number one is a sheet of regular 8.5 by 11 paper, okay? If you're going to choose one, like I just realized I did with writing on it, make sure it's not an important one, okay, because you're going to be folding it all over the place and maybe making some cuts in it too. And the second piece of equipment you're going to need is a pair of scissors, okay? So, and these are actually optional. If you can't find a pair of scissors, don't worry about it. We can do without it, okay, at the end, all right? Okay, so I am broadcasting from this place right here. This is the Intrepid, guys. So take a look at that. And take a look at that ship. Tell me what you think that was used for. What kind of a ship was it? What kind of a ship it kind of still is? You know, please share in the chat. It's pretty big. In fact, if you put the Intrepid on its bow, which is the front there that you see on the right side of the photo there. Let me zoom in a little bit more for you guys. There you go. If you ask it to do a headstand and have it stand on its bow, it will raise 913 feet into the air. And that's as tall as a lot of skyscrapers here in New York City. In fact, it's almost as tall as one of the most famous ones, and that's the Chrysler Building. The Chrysler Building, located a little bit further midtown and uptown from where we are here on the west side of Manhattan. But the Chrysler Building is 1,042 feet tall. In fact, if you laid the Chrysler Building on the deck of the Intrepid, just the end of the tower, if you can picture in your mind, will be hanging off the end. Okay, so any ideas on what type of ship this is? Anything? Well, it is, of course, an aircraft carrier, okay? Now, an aircraft carrier means, of course, it carries aircraft, and it was an aircraft carrier long before it was a museum. In fact, the Intrepid began its service in 1943 on August 16th. So we just shared that birthday, the 78th birthday of the Intrepid. It served through the latter stages of World War II. It served all during the Cold War, and it did 3 tours of duty in the Vietnam War as well, before finally being decommissioned in 1974. It's going to open up as a museum in 1982. And it's very much how you see it now when you drive or walk past it on the west side, located on the Hudson River. Also, let us know in the chat if you've ever been to Intrepid before, or if you're planning to be there again anytime soon. Okay. Okay. Why have an aircraft carrier? What's the whole purpose behind an aircraft carrier? Well, besides the obvious, to carry aircraft, of course, we know this. It provides an airport, okay? You think of Intrepid as a floating airport. We couldn't, especially in World War II, build the aircraft we were going to need to fight in that war, to fly all the way from, let's say, New York City over to Europe, or from even California over to Southeast Asia. We didn't have aircraft that could fly those distances yet. So, and nor would we use them anyway, because they would use too much fuel and be too expensive to make. So why not make the aircraft for exactly the reason that we're going to use them, for the specific purpose, put it on the deck of a flat top and sail it out to where you could easily take off and then return to during a mission. Okay, the whole reason for an aircraft carrier. Okay, all right. Another way to look at Intrepid is as a city at sea. All the things that you see when you take a little walk around your neighborhood, and maybe on your way to school or coming home from school, you might see some things like, oh, you might see some restaurants. Okay, we had real good restaurants here on Intrepid, including bakeries and not one but two ice cream parlors. Okay, so those are kind of things we had here, and just a quick example of how you could call it a city at sea. And of course, the third way of looking at Intrepid is as a battlefield, okay? Because it absolutely is as much of a battlefield as many of the more well-known battlefields around. Okay. So today we're going to be talking about aircraft and aircraft designs. So let's get to our first stop, chairs. I know what you may be saying. Chairs? What does that have to do with aircraft? Whoa, how exciting are chairs? Probably not that much, right? But you can still tell a lot about, quite a bit about a few things, such as what life was like on board on the Intrepid. Now take a look at these chairs here and try to imagine what they were used for. Okay, take a good look at them, where they might have been on Intrepid or a ship like Intrepid, an aircraft carrier. Try to imagine who may have sat in them. And while you're thinking of those things, pick out the chair that you consider to be the most common chair on Intrepid or the most boring chair on Intrepid. Okay, and if you think you have a good idea, just want to once again put it down there in the chat so we can talk a little bit more about it. Again, trying to imagine who might have sat in that chair. It wouldn't necessarily have been a boring job or a boring individual who sat in that chair. So guys, if you picked this chair to be the most boring chair, well, then you're right there with a lot of other people, okay? Because this chair is kind of a common looking chair, right? And if you did some thinking about where you might find a chair like this, you might find it in offices, okay? Yes, lots of offices on Intrepid when it was in service. Lots of offices now, of course, as a museum. And who might have sat in those chairs? Well, you could probably imagine people, sailors on board waiting to see the doctor in sick bay, sitting in the hallway waiting to be admitted. Different things like that. You might have found these chairs in the shoe polishing room, right? Very important room here on Intrepid. Got to have those shoe polishes, the shoes polished. It's an important part of the discipline. So maybe the shoe polisher, one of the shoe polishers was sitting in this chair, okay? The most common type of chair on Intrepid, right? Now look at the chairs again and tell me which chair you think seems like it's the most comfortable chair, all right? Or at least comfortable for a ship on the ocean, okay? Which chair do you think might have been the most comfortable? You're probably not looking at the one on the far left. It's probably one that's, well, it's probably not the one that's right next to that either. I can tell you that's not my most comfortable chair. If you're thinking about this chair right here, well, then you got it. Okay, the most comfortable chair is actually two of them, a set of two of them there on board Intrepid. Okay, it has a lot to do with who sat in these chairs, and if you think you might know who sat in those chairs when Intrepid was in service, you know what to do. Put it down there in the chat. We love to be as interactive as possible. Now, I will tell you that the people who sat in these chairs needed comfortable chairs. And it's not only because they were officers, it's not only because they were very, very important people on Intrepid, okay? But it is also because they were often weighted down with all the equipment that they were going to carry. So any ideas in the chat? Who sat in those chairs? If you were thinking that these chairs might have been used by pilots, okay, they're officers, very important people here on the ship, you are absolutely right. Those are pilots' ready room chairs. And here you go, some pilots from our World War II era here on Intrepid, okay? Black and white photo. And you can see some of the pilots wearing their leather helmets, not the hard plastic or metal helmets that you might have seen later on in the Vietnam War. At the bottom of these chairs, they had little drawers where pilots could keep their personal items. And all along the walls, what are you seeing? You're seeing their equipment, right? Their flak jackets, their pressure suits, also hanging from the ceiling. You're seeing you're seeing steel helmets as well, okay, that would go to other members of the crew on board. It's very important that they be comfortable, because here's where their mission commander would stand up in front of the room and brief them about the mission that they were about to undertake. And the next stop, they would be in this room for sometimes hours at a time. The next stop from this room would be to suit up, climb up the stairs to the flight deck and into the cockpits of their aircraft. Okay, so very important that that be comfortable. Okay. Now, later on, after World War II, when the pilots did climb into their cockpits, they'd be sitting in another type of chair. And that's that chair right there. Go ahead and tell us in the chat if you know the name of that chair. It looks, let's see, it's got some straps in it. Doesn't look all that comfortable. Might look a little scary to you. The pilot, should they have needed to bail out of their aircraft, might have used this ejection seat to eject out of their aircraft, okay? And it would look something like this. Now, what you're going to do, should you be a pilot or another crew member of your aircraft and you realize that you can no longer control your aircraft, you're going to reach up and pull down a handle, or reach down and pull up a handle. That'll be between your legs. And that's going to set off a two-stage rocket on your chair. It's going to rocket you out of the cockpit, like you can see on the picture on the left there. Okay, and as you notice, if you look at his head, see that blue helmet he's wearing? A little bit harder than the leather helmets that they were wearing in World War II. Okay, no ejection seats in World War II, guys. So if you were a pilot or a member of the crew on an aircraft in World War II, and you've decided that you can no longer control your aircraft, what you would need to do is you would need to unstrap yourself from the seat. You would need to reach back and you would need to pull the glass back on your canopy. You would need to climb out of that cockpit, maybe even climb out onto the wing and jump, okay? Take a little bit more time than the ejection seat if you think that you're thinking correctly. Oh, and by the way, do not pull your cord, your rip cord on your parachute too early, because you still have the tail of your aircraft to come through. And if that rips your parachute, or if it gets tangled up in those ropes, then you might have a little bit of a problem. Okay. All right. Let's see. You have ejected. Now, I want you to imagine with me now. You have ejected fully from your aircraft and you're in the water. Don't worry, you have a life vest that is going to help you float. But you need to get back to Intrepid. How are you going to do that? Are you simply going to radio back to Intrepid and say, hey, this is Lieutenant Jim, and I need to get back to my ship, and you think Intrepid is going to stop what they're doing and come and get you? If you think that, well, quite frankly, you're wrong. It's actually going to be up to another ship that's around the Intrepid in the fleet. Okay, today they're called carrier groups. It's going to be a destroyer or a destroyer escort. In World War II, they had really small ships named destroyer escorts. And what they're going to do is pull up alongside of you, and they're going to throw down your rope ladder, and you're going to climb up that ship to the deck, and a couple of members of the crew probably will help you on board. And then they will radio to the Intrepid and say, hey, we have Lieutenant Jim, and he's ready to come back aboard. And the Intrepid's going to say something like, okay, pull alongside. Now, the Intrepid is really big and it's going pretty fast, and the destroyer escort is really small, but is usually a bit speedy and can usually catch up to the Intrepid. And a couple of members of the crew on board that destroyer escort are probably going to fire over using modified shotguns cables. And then the crew on the Intrepid are going to catch those cables and fasten them to the deck of the Intrepid. And then the Intrepid will send over the highline chair, and that's the chair that's that the arrow was pointing to in our picture. The highline chair that's going to zip over to the destroyer escort, and that's where you're going to sit on the little white seat that you see there. But hold on, not so fast. Do you remember how I was talking to you about how the Intrepid was a city at sea and had, remember those 2 ice cream parlors that we had on board? Yeah, all those things on big ships like the Intrepid. None of those things on smaller ships like destroyers and destroyer escorts. Okay, so they know, the crew on the destroyer knows what we have here on Intrepid. So they're not going to just send Lieutenant Jim over to the Intrepid without any kind of ransom. Okay, so they're going to say, wait a minute, take some of your ice cream, and we want Lieutenant Jim's weight in ice cream to be put in that basket below where he's going to be sitting. So the crew's used to doing this on Intrepid, so they're going to say, okay, sure, we'll do that. So they zip you over to the Intrepid, and it's going to look something like this, okay? So, of course, the destroyer would be on the right there, the ship on the right, and there you see Lieutenant Jim, or whatever the pilot was, being zipped over to the Intrepid, right? Now, the Intrepid is going to send over that ice cream. Actually, before Lieutenant Jim gets in there, they're going to send over the ice cream, and the crew of the destroyer and say, wait a minute, because we know a lot of jokes can be played. Lieutenant Jim, taste that ice cream. And you might say, okay, taste the ice cream, no sweat. But what if the crew on Intrepid, the ice cream parlor staff, say, was pulling a joke on you and shaved some soap shavings in there, or put some hot sauce on the ice cream or something like that? So they're going to make Lieutenant Jim taste that ice cream, and if he can give the thumbs up, or at least pretend that it tastes good, he's going to give the thumbs up, and away he goes to the Intrepid. That might seem like fun, but remember, both ships are in the waves, going up and down at full speed, okay, which for the Intrepid was about 38, 39 miles per hour. Lieutenant Jim may get dipped into the ocean accidentally, or maybe even on purpose, before getting back home to the Intrepid. But you know what? No harm, no foul. It's still better than getting lost at sea after you injected, or perhaps dying in a fiery crash. All right? Okay. Real quick, let's take a break here and see if you guys have any questions. Let's check out and see if there are any questions that we can answer for you guys. How many people served on Intrepid? Good question. So it depends on what era you're talking about. If we're in World War II, we're probably talking about 3,400, right? 3,400 men on board. Sailors, because that number does not include about 100 Marines that were on board as well. And what the Marines are going to do is they're going to fire the anti-aircraft guns, provide general security for the ship. So if you are a bad boy on Intrepid and you act up, you might get tapped on the shoulder by a Marine, and he might take you and put you in the brig, okay? That's a naval term for jail. And on Intrepid, there were six cells, okay? So you might have to spend a little stint in there before you calm down. It also did not include the pilots and crews of all the aircraft, known as an air group back then. So closer to 4,000 men. If we jump ahead to the Vietnam War, we're talking more like 3,200 men on board with the same restrictions. A few less Marines on board as well. And the aircraft were known as an air wing instead of an air group, okay? So a city at sea, indeed, right? What's our next question? Do we have any other questions out there? Oh, how many planes do you have at the museum now? Okay. Oh, and frankly, that's great timing right there. How many planes do you have on the Intrepid? Well, we have about 28 aircraft, okay? 28 aircraft, including our British Airways Concord, all right? So definitely make your plans to come visit us, and hopefully you'll even run into me, so you'll know what I look like. If you see me, please come over and say hi. Okay, guys. Let's see. Take a look at this aircraft. All right, this is one of our most popular aircraft. Now, if you are a superhero fan like me, and you love the Marvel movies, you'll know the Avengers movies. Okay, but before we had Iron Man, the Hulk, and Thor, this was our Avenger. Right, it's the name of this aircraft. It's our TBM Avenger. Now, really quick, take a look at this plane. See what you could see about it. What catches your eye? What do you think the job of this airplane was for? We are talking about aircraft designs. So what do you think this aircraft was designed specifically to do? Give you a little hint, maybe. You might want to pay attention to something below this aircraft on the bottom. Pay attention to the wings as well. And if you are thinking that that thing on the bottom is a torpedo, that is exactly correct. Okay, that is our Mark 13 aerial torpedo. And what this plane, it's 2,000 pounds, and this plane can only carry one of those, okay, up in these bomb bay doors. And it had one job, and that's to drop that torpedo into the water. Hopefully it will swim through the water and impact an enemy ship, make a big hole in the ship, maybe even sinking that entire ship, okay? But to do that, you're gonna have to fly sometimes as low as 200 feet off the waterline. You're gonna fly slow. The top speed of this aircraft was right about 275 miles an hour to begin with, which is real slow compared to the aircraft that we see today and are using today. And that we'll see later on in this presentation, and try to line up that torpedo shot, okay? Meanwhile, you're being shot at by all those enemy ships. Anyway, a very important part of an aircraft, of course, is the wings. Now, I asked you a little bit earlier to take a look at the wings here. Tell me about the wings. What does it look like? Does it look like the wings are broken? Does it look like maybe something the museum did in order to get this plane to fit inside an area called the hangar deck? Okay. If you're thinking that maybe it's folded on purpose, then you have the correct answer. Okay, so do me a favor, and we're going to try a little something at home. I want you to pretend that you are an airplane. I want you to stick your arms straight out like this. All right, okay. And, you know, do a little turning and twisting. Hopefully you don't knock anything down on your desk. Okay, I almost hit my glass of water that I have over here. That would not have been good. All right. And imagine your arms are 54 feet long, right? In total, both your arms together. And that was the wingspan of this Avenger. Now, here on the hangar deck, we had limited amount of space. Okay, let me give you that picture one more time. You can see the ceiling there, right? 54-foot wings do not fit into, a lot of them do not fit into this hangar deck. But there were a whole lot of aircraft on board, and so we had to fit as many as possible. So I want you to do one last thing and take those wings, get your wings out. I want you to fold them. And if you fold them like this, let me put me a little bit bigger on the screen there. If you fold them up like this, well, you're going to have more room next to you. Now do that same turning motion, okay? I'm not near my water anymore. Hopefully you're not knocking anything over it either, okay? But if you have 54-foot wings, your wings are still high up in the air, okay? And it's possible you can hit the roof of the hangar deck. Take a look at the hangar deck again. It's not open air. And also, and if you've ever looked at a bird flying, and I want you to do this experiment if you walk out today. I know it's a little hot for you, but if you're like me, you love the hot weather anyway. So just take a look outside your window perhaps, or while you're walking home, and try to see a bird. When a bird lands, does a bird fold his wings like this? Nope. He folds his wings behind him like this, kind of like the Avengers doing right there. This was a very, very important new design by Leroy Grumman, who was the head of Grumman Aviation, big important part of Long Island's history. And this allowed you to fit a lot more of these Avenger aircraft in the hangar deck, okay, with those long 54-foot wingspans. Okay. Now, the Avenger was not exactly a majestic aircraft flying through the sky. If it looks very heavy, it certainly was. It had one name that pilots who flew it. It's not very complimentary. They called it the Turkey. Now, we love turkey, especially come around Thanksgiving time, right? If you've ever seen a wild turkey, we do have a lot of wild turkeys in the whole eastern part of the United States here. So if you've ever seen a wild turkey, you'll know a couple of things. You'll know, one, they're pretty mean and vicious birds, right? But the one I'm getting at here is the other one, is they're not the best flying birds, right? So you could, I guess, say, we're talking about design for flight. Turkey's not exactly designed for flight very well, right? But the pilots who flew these Avengers called them the Turkey. It wasn't a great flying airplane, okay? Remember, designed to do one thing, and that's to drop that 2,000-pound torpedo, and that's pretty much it. So if it wasn't a majestic airplane, if it wasn't a good flying aircraft, then how is it able to stay in the air? Well, that's our first force. It's called gravity, okay? There are 4 forces of flight. And the first one is gravity. I want you to do another quick experiment. I want you to pick up a pen or an object that you have, a light object, nothing heavy, nothing difficult to lift. And I want you to hold it up like this. And I want you to put your hand underneath it, right? And on the count of 3, we're going to let that object go and fall into your hand. Ready? 1, 2, 3. Okay? Obviously, the pen fell into your lower hand. It was being pulled down by gravity. Gravity acts on everything on Earth, and it's actually pulling us down. It's pulling us to the center of the Earth. Okay, that's our first force involved in avionics, in flight, is gravity. Okay, but we know the Avenger wasn't a great flyer, and gravity probably, it was very heavy, and gravity probably acted on it very well. It sure did, but it had to it had to fly. So what was it going to use to fly? I want you to take another look at the Avenger here. And see where the arrow's pointing? Is pointing up to the front of the Avenger. And what's that thing called? It's black. It's got red painted tips. It seems like it kind of spins. It's got 3 blades on it. What do you think that is called? Just put it down there in the chat. Hopefully you're still with me here. It does indeed spin. That is the propeller. If you're thinking it's a propeller, absolutely. And the propeller is actually going to do what to the Avenger? It's actually going to move it forward, okay? And that brings us to other kinds of propellers that we had on the Intrepid, and still have today as part of the museum. Now, again, on the left is our Avenger with its big propeller. But on the right is an even bigger propeller, okay? That is a big bronze propeller. It's one of 4 that were on the back of the Intrepid to push the ship through the ocean, okay? So propellers can not only be on the front of your vehicle, but could be on the back as well. Oh, and by the way, if you're thinking a 3rd type of propeller might have been on the back of the Torpedo, the black Torpedo down there on the bottom of the Avenger, you're absolutely right, okay, to move that through the water as well, okay? Propellers are going to propel, push or pull us, and give us our second force, thrust, okay? Thrust is going to act in the forward direction, right? Thrust pulling us forward, gravity pulling us down, right? Okay, there are other methods of producing thrust, though, besides propellers. Yeah, we still do use propellers today on a lot of aircraft, but they're not as common as they were back in, say, World War II, okay? Today, you might see aircraft that look more like this, okay? This is our Fury, and it's one of the first type of jet-powered aircraft to serve off of aircraft carriers, our Fj3 Fury. Now take a look at this aircraft, just like you did with the Avenger, and see what you might see about it. What are things that you notice? If you notice anything exciting, or specifically how it's different from the Avenger, put it down there in the chat. Okay, it's pretty different. The colors are pretty different, that's true. You might take a look at these wings on the Fury, and you might realize that the wings are folded up, okay, because they're not quite as long as the wings on the Avenger, and there'd be room in the hangar deck. But the thing that you might be coming to is that there is no propeller on this aircraft, right? It's a jet aircraft. Basically, the whole body is its engine, and this produces thrust in a different way. So it has no propeller to pull it through the air. It has jet engine to push it through the air, okay? What it does is it sucks in the air. It's going to compress that air. We're going to put some fuel into that compressed air. We're going to ignite that fuel, and we're going to shoot the hot air out the back, and that produces thrust in the forward direction. Okay, so two ways of producing thrust. But look at the wings a little more closely, and you might see how the wings are not straight out like our arms were before, right? They're not straight out. They're kind of swept back, swept back. It was actually the Germans in World War II that discovered if you take your wings and you sweep them back, that will reduce another force that's acting on our aircraft, okay? It's actually acting in the opposite direction, and that is going to be in the opposite direction of thrust, I mean, okay? Now, a little quiz, guys. Which plane do you think is faster? Do you think it's the propeller-driven Avenger? Or do you think it's the jet engine-driven Fury? Now, we already know the swept-back wings aid you in some way. So that could be a little clue that I gave you before. They're both heavy aircraft. They're probably comparable in weight. If you are thinking it is number 2, the Fury, well, you're the winner, okay? Like I told you, 275 miles per hour was basically the top speed of the Avenger. When the Fury got up real close to 700 miles per hour, about 658 miles per hour or so. All right, 681 miles per hour on our Fury. All right. Now think about the design of those aircraft again. And think about that swept wing design that the Germans first came up with in World War II. And I told you that it reduced this third force that's acting in the opposite direction of thrust. Thrust is pulling us forward, or in some cases, pushing us forward, right, depending on the aircraft. And the force that's acting in the opposite direction, you got it, drag, okay, drag. So those swept back wings are going to reduce the force of drag. And by the way, remember when you ejected from your aircraft and pulled your parachute and were floating down towards the ocean, getting ready to be picked up in your highline chair? Well, the force of drag is also acting on your parachute too, okay, along with the force of gravity. So the force of drag is actually slowing you down. All right, very good. Let's see, what else can we do here? Let's take a look at this video. Now, you don't just want to go up and down, forward and or backwards if drag overwhelms you in your aircraft. You want to be able to do turns. You want to be able to gain height. You want to be able to lower your altitude, get lower. You want to be able to turn in different directions, okay? So those are going to be done by control surfaces. Take a look at this video here. Let me put that on for you. So once again, our Fury, guys, okay? And we're moving around to the front there. All right, it says jet intake, and it's painted red. It's painted red for a reason, and that's because it's dangerous, okay? That is sucking air into its jet engine at quite a speed. And if you're walking by, you may have a little problem. You don't want to get sucked in there. So give it a lot of leeway. Let's move over to the wing. Look at that. I want you see that little red in there, that little red shape? I want you to pay a lot of attention to that, okay? Pay a lot of attention to that. And let's see, where am I here? We're going to skip. Okay, so there you go. That's the shape of the wing, okay? It's not just rectangular. Wings are shaped in a very specific way. They are designed, once again, to keep our aircraft, some of which are very heavy, some of which are going to be a lot heavier than the Avenger even, to stay up in the air, okay? The shape of this wing is called the airfoil, okay, the airfoil. And this is how the wing going through the air, this is how the airflow works around our airfoil, okay? It is designed so that when this is flying through the air in our Avenger, say, or our Fury, because you see it's kind of slanted back, swept back, so you can say it's a Fury wing as well. the air is going to flow under it and over it. Now, because of this unique design, air flowing underneath the airfoil is going to create a area of high pressure. Air flowing over the top is going to create an area of low pressure, okay? And in nature, flow occurs naturally from areas of higher concentration to lower concentration, okay? So if you have high pressure on the bottom, low pressure on the top, your motion is going to tend to go upwards, okay? And that is actually going to give us our next force, lift. Look at that strong guy carrying just a heavy weight with just one arm there, lift. So lift is going to bring us up, and it's going to counteract the pull of gravity pulling us down, okay? All those are our four forces, okay? By the way, I was talking about observing birds before. When you're out later today and you look at a bird that's coming in for a landing, not only does it put its wings back, okay, but before it lands, it's using its wings, of course. What shape do you think the bird's wings are? Any idea? Yeah, the feathers are very important, and the birds are very light. You know, they have honeycombed bones, not solid bones, to make them light. So this way, gravity won't be much of a problem for birds. But if you think that a bird's wing is shaped like an airfoil, you're absolutely correct, guys, okay? Science mocks nature. Not mocks. They imitate nature. Yes, you're a fool if you mock nature. So you're going to be imitating nature. So what works for a bird works for our aircraft as well. All right. So let's see. Back to our maneuverability. And if you're thinking about maneuverability of aircraft, there's absolutely no better aircraft to look at than these guys right here. This is our Blue Angels, guys. This is the Navy's precision flying team, the Blue Angels. And today they use the FA-18 Hornets. Now the Air Force has a precision flying team as well, and they are called the Thunderbirds, okay? They are using the F-16s. We actually have an F-16 on our flight deck. You can check out when you come to visit us, okay? These guys are the best of the best pilots, Blue Angels and Thunderbirds. As you might imagine, a little competition between the two groups, okay? The Thunderbirds and the Blue Angels. I know for a fact that the Blue Angels kind of call the Thunderbirds the Thunder Chickens. Just some friendly rivalry there, okay? But we do know that these guys are the best pilots and they can maneuver these aircraft. These are some of the best aircraft around, but how do these aircraft maneuver? Well, you need some control surfaces for that. So let's go back to our video. And again, we're looking at our Fury. See, those wings have some clearance there, but what you're looking at the bottom of the wing there is called an aileron, okay? And ailerons is a French word. It means little wing, okay? As you saw my colleague's hand doing this motion, okay? That's called roll. So when an aircraft does any of this motion, it's called roll. And that's the first axis, if you will, that these aircraft are going to pivot on. And they're going to use the ailerons to do that. Yeah, as you can see, more rolling motion. Moving on to the rear of the Fury, you have a couple of other cutouts there, don't you? This is the elevators, and like my colleague's hand, this is going to move us along our second axis. It's the pitch axis, and that's moving our hands up and down, okay? Pitch. And our yellow cutout there that my colleague is pointing to, that's the rudder, and that's going to bring us on our third axis, and that is yaw, okay? That's our yaw axis. So we have three ways our aircraft can move: roll, pitch, yaw, okay? There we go. All righty, I think it's probably a good idea. We can stop here for another question break. Let's see if there's any questions. Hopefully you guys have a couple in there. Oh, are Avengers still flown in the Navy today? So unfortunately not. Well, maybe in air shows you'll see an Avenger flying. In fact, I think I saw one a couple of years back on 4th of July. But generally, you're not going to be able to see any of those old aircraft still in use by the Navy. They did gain use or continued to use them for several years after World War II. In fact, you could find a lot of them put into civilian use. For example, putting out forest fires, helping to do water drops on forest fires, okay, like is very unfortunately going on out in the western part of our country and other parts of the world here. So after World War II, a lot of them would be put to use doing that as well, but no Avengers flown today. Good question. Is there another one? Why are the Avengers Wings so big? Okay. Yeah, especially since the bigger the wing, the harder it's going to be to fit in the hangar deck, right? We talked about that. The bigger the wing, the heavier the aircraft is going to be. And ideally, you don't want a really heavy aircraft, right? Or otherwise, you'll have to provide more lift for that aircraft. And remember when I was talking about how Avengers were designed for one purpose, and that's really to drop your 2,000-pound torpedo, right? You have to have a robust, a strong aircraft, okay, to hold 2,000 pounds, even if you only held one, okay, because you also have a 3-man crew you have to have on that Avenger as well. The bigger the wings, the more lift perhaps you will get from a longer wing surface that is creating a larger low pressure area to lift up your aircraft. Okay, that's actually an excellent question there. Very good. All right, just to kind of summarize our 4 forces, here you go. Gravity's pulling us down, right? The apple fell from the tree, hit Isaac Newton on the head. Lift is going to act in the opposite way and pull us up, right? That low pressure forming on the top of the wings is going to pull us up. Thrust from propellers and or jet aircraft are going to propel or push us in the forward direction, and that is counteracted by drag, okay, which is it's a drag, if you will. You're probably way too young to know what I mean by that, but it's kind of holding you back, okay, counteracting your thrust. And hopefully, if your thrust is stronger than your drag, you will fly in the forward direction. Okay, all right. Let's take you in a quick look at the flight deck. Okay, that's the deck, one deck above the hangar deck, the deck that you saw in the first couple of pictures of this presentation. It's where airplanes took off and landed from. Remember, we were talking about aircraft carriers as floating airports. Okay, airports both receive planes and launch planes, and the Intrepid and aircraft carriers were no different. Okay. But remember when I said that the aircraft carrier was 913 feet long? That's pretty big. But to do all the things you need to do up on the flight deck, it's really not all that big. So special things have to be done to the flight deck, and special crew have to be trained in order to make it happen. When thinking about the flight deck, I want you to divide it into 3 separate areas, okay? The first area I want you to divide it into is the back 1/3, okay? The back 1/3 of that flight deck, and that's where we're going to be, landing our aircraft, okay? The front 1/3 of that flight deck, we're going to launch and take off our aircraft, like you see what's going on right here, okay? The middle third of that flight deck is going to be used for bringing new aircraft up on the aircraft elevators, getting them ready to fly, refueling and rearming aircraft during time of war, okay, and then moving them to the front 1/3 and launching them. Now, you only have about 250 feet or so of room to take off, and if you're kind of thinking that that's not a lot of room, you're absolutely correct. So a lot of these aircraft, particularly the heavier ones, particularly the heavier jet aircraft used later on in the Vietnam era, are going to need a little help. So I want you to check out this picture here. And if you could see this jet taking off, yeah, you can see the exhaust coming out of the 2 engines in the back, but you kind of see this little line going behind the aircraft there, okay? That's a little groove where a bridle is put. It's called a bridle. And that is a part of our aircraft catapult. Okay? Now, no, it's not a medieval siege engine throwing a big boulder at a castle wall trying to break it down. It is more like it's more like a slingshot, okay? So if you have a slingshot, maybe you threw a paper at your little brother with through the slingshot. it's going to sling or catapult these aircraft, heavier aircraft, in only 250 feet, go from about 0 to about 150 miles an hour in about 3 seconds or so, okay, depending on the plane. So that's the help the planes had to take off. So remember when I said the back third of that aircraft carrier is going to be reserved for landing aircraft or recovery operations? They're going to need some help too, planes coming into land on that same 250, not the same 250 feet, but that same distance, 250 feet, okay? So if you see here in the red circle, you see that white and black striped device there, kind of tucked underneath the tail, all right? That will give you a hint to its name. It's called a tail, and if it looks like it's kind of shaped like a hook. There you go, a tail hook. So all naval aircraft have these tail hooks tucked underneath the tail. And by the way, if you ever see an aircraft with a tail hook, you know it's a naval aircraft, okay, designed for operating on aircraft carriers. So coming in for a landing, the pilot is simply going to drop that tail hook, as you see in the first picture there on the left. Okay, see the tail hook drop down. And then they're going to plop down on the back 1/3 of the aircraft carrier in hopes of catching that hook onto one of 5 these days, sometimes as little as 3-inch-and-a-half thick steel cables that are laid across the back of the flight deck. They're called arrestor cables. And when that hook grabs onto that cable, it's going to bring you to a stop, a pretty sudden stop. It's going to bring you from about 150 or so to 0 in that same 2 seconds. Kind of the opposite as the takeoff there, all right? So the pilot is well strapped in. He's got his flight suit on him, his pressure suit, but it's still quite a jarring stop. If you're into roller coasters like I am, it's a little bit, it's like an extreme roller coaster, all right? And that's going to bring that aircraft to a safe stop. As soon as that hook grabs onto that arrestor cable, the engines will shut down. The pilot will be disconnected by the flight crew, and that aircraft will be moved up to be refueled, and then moved up to the first third to take off once again. Okay. Lots of different kind of aircraft that we have on Intrepid, guys, including this kind of aircraft. Okay. What is this called? This is an aircraft for sure. It doesn't seem to have a propeller on it. Or does it? I don't know. You can see that it is red and white painted. And if I give you an even closer view, you can kind of see the name, the word coast, and one of the rotors is blocking the name. This is our Coast Guard Seaguard, okay? And it's a search and rescue helicopter. This aircraft like this had one job, and that's to go pick up Lieutenant Jim or other downed pilots in the water after their planes malfunctioned or were shut down. And you go and rescue them by using these guys, okay? But back to the question of, does it have a propeller? I mentioned the name rotor, and you can see the rotors are folded back. So the rotors actually act like a propeller, but they're on the top of the helicopter, okay? And if, by the way, if you were to take one of those rotors and look at it edge on, okay, look at it edge on, what shape do you think that's going to be in? What shape? If you might be thinking it's a shape that will gain lift. Yeah, you got it. Okay, so it is definitely going to act like an airfoil. Okay, so those rotors are going to pull this helicopter straight up. It's one of a type of aircraft we call VTOL, VTOL, vertical takeoff and landing. All those kind of aircraft can take off straight up, land straight down. Okay. Let's see, other design features that can lead us to VTOL motion, taking off straight up, landing straight down. Check out this aircraft, okay? This is our British designed Harrier jump jet, okay? I want you to take a good look at this aircraft, and hearing or knowing everything that we heard from this presentation, things that you've learned, what are some of the design features you can see on this aircraft here? Okay, let me zoom in for you. Take a look at the wings. Take a look at the wheels. I want you to take a look at the engines. All right. Specifically, oh, I guess you can't see my cursor, but specifically, if you can see, I tell you what, you can see it now. There you go. If I turn on the laser pointer, what do you see right over here? That's very important. Okay, that is something that other aircraft, that few other aircraft have. If you're looking at the wings, you might see that they are swept back. Okay, they certainly are. Okay, you might see this big thing protruding to the side here. That is our refueling nozzle. Okay, because this plane capable of being refueled in mid-flight, another design feature. Okay, but what I was showing you are the vents on the end of all these jet engines, and that is a variable vent on the back of the engine. It can change the direction of the jet output. Okay, and if those are pointed down, instead of going directly behind the aircraft to push it through the air, you're going to have that thrust aimed down. It's called vectored thrust. It's going to push you up in the air. So it's another way to gain VTOL flight. Okay, very good. All righty, let's see. A couple of my favorite aircraft here in this picture. Another quick quiz for you. Which aircraft is designed for faster than sound or supersonic flight? If you think it is aircraft A, of course, put A in the chat. If you think it is B, put B in the chat. Which aircraft is designed for supersonic, which means faster than the speed of sound flight? Okay, these are two of our most popular aircraft. Some answers coming in there. I don't think I'm going to fool you guys with this one. Yeah, Vash and Wendy, yeah, you guys got it absolutely correct. If you said A, you are absolutely correct, and that's our A-12. Okay, I see Daddy, you got it absolutely right there. Daddy Marks, our A-12. This is a surveillance reconnaissance aircraft, Cold War operation by the United States to spy on our Cold War adversaries, the Soviet Union and their allies. Okay, look at this aircraft. Yeah, answers still coming in. You guys got it. There was no fooling you guys. Okay, you can see how this aircraft is very sleek in design. There are very few harsh angles. Okay, very few angles like right angles. Just, you know, for example, it's more like sleek design. Okay. So as you can imagine this thing slipping through the air, you can imagine the force that's acting opposite the thrust, which is what again? Remember, acting opposite the thrust starts with a D, drag, okay? You can imagine the drag being lessened by that sleek design. So as opposed to this aircraft, that's our A-6 Intruder. This was a ground attack aircraft that could carry a whole load of bombs, around 20,000 pounds of bombs. Now, whereas our A-12 was kind of long and thin and sleek, our A-6 Intruder is kind of short and stubby, isn't it? That'll give you a hint that this is a slower than sound or subsonic aircraft, okay? So when you come to the Intrepid, or when you look at any other type of aircraft, if it is long, needle-shaped like a dart, it might just be a supersonic aircraft. Short and stubby, chances are it is a subsonic aircraft, okay? We do have another supersonic aircraft. We have a few of them at Intrepid, but another one that's very, very popular, and that is our British Airways Concord here. No longer in service, but the absolute fastest commercial airliner ever made, capable of speed of Mach 2. A-12, by the way, could go faster than Mach 3. So not quite as fast as our A-12 is our Concord. Okay, okay guys, so what I'm going to do is I'm going to get you on to your activity. So I want you to follow along with this video. And it's my colleague, once again, is going to show you what to do. Take that piece of paper, and I want you to fold it lengthwise. Go ahead and make a crease. Okay, so you should have a fold like that. Disregard the numbers. Don't worry about those. Fold the inner corners in like he's doing. Okay, so that's one on the right side. Make sure you do it again on the left side. Okay, and go ahead and make those nice tight creases. You can fold them, right? Then go ahead and take where he pointed to the number 3, and you're going to fold them one more time, okay, in towards the middle, the center line, what you're seeing right there. Right, once again, fold that in towards the center line like so. And he's pointing to his number 4 there. You do the same thing on the left side of the piece of paper so that everything is symmetrical, everything is the same. There you go. Again, harden those creases. Very good. And then what you're going to do is I want you to take the entire thing and fold it in half along that original fold that you made on that piece of paper. Okay. Okay, and you can go ahead and sharpen those creases so that things stay in place a little bit better. Okay, that's what it should look like. Then I want you to do what he's doing there and fold those wings down. You're going to make your wings of your aircraft. Okay, go ahead and once again, always sharpen those edges just to make them kind of stay in place a little bit. So once again, do that. Fold your wing down. Aircraft usually need more than one wing, so we're going to make our second wing, and we're going to fold it the same way we did that first wing. Okay. And again, sharpen those edges. Okay, spread your wings out. Ta-da! You have your aircraft. Okay. All right. Now I'm going to stop it here because I want to do the next part live with you guys. So take your aircraft. I have mine pre-made right here. And remember those scissors? Grab your scissors. Or if you don't have scissors, you can use your hands and kind of tear into the back. You see the back here. We're going to add some elevators to our aircraft in the back. So make a couple of little, maybe half-inch cuts. Okay. And you can see how I've made that here, right? And another one on the left side, and you can fold them up. Okay, you can fold them up, you can fold them down, you can fold them any way you like, and just try tossing it around your room, your living room. Make sure that you don't annoy your parents too much. Okay, you can also add a rudder here, right, on our horizontal, on our vertical stabilizer. That same half-inch cut. And again, you can fold that to the left, you can fold it to the right, and just go ahead and have fun, guys. Okay, toss it around, see the directions that each of these control surfaces, right, makes this thing fly. So guys, I want to, you've come to the end of the presentation. And I want to thank you guys once again. Thank you so much for joining us on the Intrepid Virtual Adventures program. We're going to have another one next Tuesday. It's going to teach you all about naval slang, and it's called Anchors Away. So if you're interested in Navy life and naval slang, okay, we promise we won't get too salty on that one. Okay. So guys, thanks once again for joining us today. And on behalf of Alicia, my assistant as well, we'll see you next time.